Good morning, everyone. I am Omshi GA from GM University, Davanagere. We are from Cybersecurity Department. Our title is ESP32 GPS Tracking Live Tracking. This project is presented by our teammates Sujanar, Omshi GA, Yashwant Tel, and Yashwant PS, and Bharat Taran. We are currently in third semester under the guidance of Nayana MR. We can present here. Content: Introduction, Literature Review, System Design and Implementation. Introduction. In today's world, real-time location tracking has been very important in many domains such as vehicle tracking, personal safety, assessment monitoring, and smart systems. With the growth of IoT and cloud connectivity, tracking systems are no longer with the offline GPS device. Instead, now we can live data to the internet to be accessed from anywhere. The main goal of our project to design and implement a simple low-cost GPS tracking using the ESP32 microcontroller. This project is inspired by tutorial and how the ESP32 works and the GPS model. Free cloud API can be combined real-time location tracking efficiently. Our system commonly fetches GPS coordinates and uploads the cloud, enabling live monitoring. Next slide is explained by Sujana.
Literature review. Live tracking commonly used MQTT or Firebase for real-time map dashboards. Lightweight Kalman filtering is used to reduce GPS noise and improving tracking smoothness. ESP32 is widely used for a GPS tracking in 2024-25 because of low cost Wi-Fi plus Bluetooth and easily introduction. 2024 papers highlighting increased GPS spoofing risk and so secure TLS communication and anomaly checks are recommended. System design. The ESP32 tracking system is designed to monitor and transmit real-time location data using a combination of the ESP32 microcontroller and the Neo 6M GPS model. The GPS model receive a satellite signal and calculate essential parameters such as latitude, longitude, and altitude and speed. The ESP32 acts as the main controller that reads the GPS data through a serial communication and upload its web server or IoT platform for live tracking.
Implementation, hardware implementation. Now I am coming to core component of our system is ESP32 microcontroller, which is used for uh, both data processing and Wi-Fi connectivity. For location tracking, we use GNSS model such as Neo 6M, which is provides latitude and longitude data processing using satellite signals. The GPS model is connected using ESP32 serial communication to power communication as lithium ion battery. In this, we use USB cable along with charging module, voltage regulation to ensure safe and stable operation. For testing and prototype purpose, all the components assembled in breadboard make the system easy to modify and debug. Next, software implementation. The firmware of ESP32 is developed by either the Arduino IDE or ESP-IDF, depending on the configuration. GPS data which receives the passed using libraries such as TinyGPS++ are built in extract latitude and longitude values. ESP32, which uses Wi-Fi communication libraries to connect internet to send the data to the cloud. The software logic which periodic GPS sending the data, filtering proper packet form using transforms. We can also implement like error handling mechanisms to use the GPS signal logs when the disconnection and atomic repair. Finally, the real-time dashboard is created using Firebase or custom API. The live token can be visualized on the map.
Hello everyone, myself Ashwant. I am explaining about implementation, integration of hardware and software. And this slide will be explained complete about the integration and with between hardware components and software systems. Like the communication ensures the reliable GPS data transfer to ESP32. We know that the core hardware components is used used in this project is GPS module especially, and the Neo 6M module, and circular chip controller, the main controller, ESP32 microcontroller, and the GPS module is responsible for every receiving signals of multiple satellite, like calculating the geographical information such as longitude, latitude, and altitude, speed, and UTC time. The GPS data is transmitted to the ESP32 using the serial communication, and ESP32 formats the data like JSON payload, and the communication modules transmits that proceeding to data to the main server or the broker. And once the data is praised, the ESP32 process the structure the information into the reliable format. It checks that error is placed or not, and if performed, to ensure then valid or noisy data is filtered, and system tested for synchronized latency and stability across the module. And next slide about the communication protocol data handling. And the main point about it HTTP. We know that HTTP hypertext transfer protocol, it's a simple request response to make a method for uploading an location data to REST API. Like the data can transmit the HTTP protocol is used ESP32 GPS tracker, GPS data, cloud server using HTTP post request. That cloud server acts like an receiver before sending the GPS data formatted into the structure. JSON packet, JSON is chosen because lightweight, easy to praise, and widely supported by cloud platforms and web application. And next one is Wi-Fi. high speed high speed link for cloud connectivity during indoor and urban tracking. And data handling, data formatted into JSON and SCV packet. We know that SCV means cascading separate version, and it's sent to cloud, stored in database, and displayed on map dashboard. And it properly the data can handle ensures the reliability, security, and accuracy of the tracking system, making it scalable for real world applications. And filtering and validation applied before the sending to avoid a noisy reading. Next topic will be handled by Ashwant.
Hi, myself is Ishwan, architecture designing. This slide focus on a communication whether here methods of data handling technique using in this system. In this you can see that the system using the Wi-Fi as a primary communication medium, as it provides a high speed internet access and low latency. This makes stable for a real-time GPS tracking application. For data transmission, the HTTP protocol is used to ESP32 sends GPS data to the cloud server using the HTTPS post request. This means follow the client server's architecture, where the ESP32 acts as a client and the cloud server acts as a receiver. Before sending, the GPS data is formatted into a structured JSON pack. JSON is chosen because in the lightweight, easy to phrase and widely to supported to the cloud platforms and web applications. On the server side, incoming data is received, decoded and stored in a decoded form, data stored in a database. This stored data can be later be used in a tracking history, routing analysis and performance evaluated. Proper data handling ensures the reliable security and accessory to treating system, make it scalable for real world applications. Next, let's discuss about result and discussions. In this slide, summarizing the results obtained after the implementation and testing the system, the GPS tracking system successfully demonstrated real-time location tracking with high access in an outdoor environment. Latitude and longitude value were consistently and reliable during the test. Data transmission over the Wi-Fi was stable, and live location updated were displayed on the dashboards with mainly delayed. The system performed efficiently even during the continuous tracking. Power consumption was optimized through efficient task scheduling, makes the system stable, suitable for a long durations deployment. The overall performance indicates that the system is scalable and adaptable for the real world applications such as vehicles tracking and logistic management and um, personal safety monitoring and aesthetic tracking. In considering the project meets its objective by the delivering a reliable, co-effective and real-time GPS tracking solution. Next will be explained by Bharat Aram.
Myself, Bharat Aram, challenges and solution. Challenge solution GPS, GPS signal delay during the setup. Uh,